In this video, we're going to talk a little bit about expressions and equations, how you see them verbally, and also how you can write them. Our I can statement is to write expressions and equations involving variables. So let's get started. I'm going to start by reviewing an expression versus an equation. Remember, an expression is a statement. It does not have an equal sign. An equation has an equal sign, and it shows the relationship between the two sides of the equation. All right, here we go. We have some expressions, and when you're thinking about expressions, you want to think about the operation that is happening in it. You want to visualize, you want to be able to see this mathematical situation so that you can determine, is this addition, subtraction, multiplication, division, and that is going to help you write your variable expression. So I have a box of donuts and it is being shared. When I'm sharing, I'm dividing. If I have two boxes, one box times two boxes would be multiplication. A box of donuts with 3 donuts missing. If something is missing, it is subtraction. A box of donuts and 1 additional donut. If I have 1 additional donut, it means I'm adding. So I have a box that I've added 1. For my subtraction, I have a box that has 3 missing. I've subtracted 3. For my multiplication, I have a box times 2 boxes of donuts. And a box that is being shared is a box divided by 4. So you have your variable expression. So that is that statement that uses a variable to show you a mathematical situation. So before we were looking at mathematical situations, thinking about the operation, and then looking at the variable expression that went with it. Now I have verbal expressions. And with our verbal expressions, we want to think about the operation being used as well. 6 less than a number. Less than is subtraction. A number divided by 9 would be division. 5 times a number would be multiplication. 6 more than a number is addition. So for these are the verbal expressions. They also match a variable expression. I can use a variable expression for these. 6 more than a number, I would have a variable for the number and then add 6. It's 6 more than that number. 6 less than a number, I can have a variable in place of that number. 6 less than would be n minus 6. 5 times a number, n for my variable times 5. A number divided by 9. So you can see you can have those mathematical situations, the verbal expressions and variable expressions that go with them. Notice none of these have equal signs. So these are just statements for those mathematical situations. When I have an equation, my equation has an equal sign. And I can also visualize these. I can create pictures to try to figure out what this equation means. What is it saying? In this case, I'm going to use candy for these next few so that you can see what this equation is showing us. So for this one, I have n first, n plus 5 pieces of candy. And the n and the 5 pieces of candy added together give me 12 pieces of candy. So you can see I have n plus 5 pieces equals 12. Both sides of my equation are the same. They are equal. All right, now let's look at subtraction. I know I have 12 pieces of candy, and I'm taking away n. I don't know exactly how many n is, but I know I'm subtracting some of this candy, taking them away. In the end, I'm left with 5. So I know that 5, the right side of my equation, is equal to 12 minus some. Both sides of my equation are equal. In this case, I have multiplication. I have candy. I have n amount of candy. It's a variable and unknown. I don't know how many is there, but I know that I'm multiplying it by 5. So I have 5 of this N. And all together, it would be 15 pieces. That candy, N times 5, equals 15. Okay, here I have division. I'm going to start with my 15 pieces, and I know I'm going to be dividing them. I'm going to be dividing them into N groups. So dividing into groups with 5 in each group, because each group equals 5. All of those groups together, 15 pieces divided equals 5. Okay, now we're going to look at a mathematical situation, see if we can illustrate that, really see what is happening to write a variable equation, an equation with a variable in it. Madison bought 3 new notebooks. She now has 5 notebooks. Which equation can be used to find N, the total number of notebooks Madison had before she bought the new notebooks? So N is the number she had before she bought new notebooks. I know I have N notebooks. Then she bought 3 more. Now she has 5. So when I'm writing my equation, I have an equal sign. I have to think about both sides of that equation. I know I have N plus 3 more, and that would equal 5. N plus 3 equals 5. 4 full boxes of popsicles equal 48 popsicles. Which equation can be used to find P, the number of popsicles in each box? So I'm going to think about what I know, what I have. I know I have 4 full boxes of popsicles. Altogether, these popsicles equal 48. What type of math would be involved? What operation would I use if I have 4 full boxes of popsicles? Thinking multiplication. When I have groups of something and each group is the same amount and I know how many groups I have, I'm multiplying 4 times the number of popsicles in each box. Nevaeh planted 7 fewer flowers than Asia. Nevaeh planted 19 flowers. Write an equation that can be used to find A, the number of flowers Asia planted. So I'm going to start with what I know, and I know that Nevaeh planted 19 flowers. With an equation, I have 2 sides of that equation, and those 2 sides are equal. Nevaeh planted 19 flowers, which is the same as the number that Asia planted, minus 7. Nevaeh planted 7 fewer flowers than Asia, so I would have the number of flowers Asia planted, and 7 fewer than that would be 19. I could also say it this way. I could also say A minus 7 equals 19. Sean has 15 students in his class. He placed his pencils into even sets and gave each student a set. If there were 60 pencils, which equation can be used to find C, the number of pencils each student received? I'm going to think about division for this one because I know he is placing his pencils into even sets. And when I am dividing something into even sets, I'm thinking about division. So I know I have 60 pencils. He put them into sets and he's dividing them out. And he divided them out among 15 of his classmates. So I have 60, and the variable in this case is going to be the number of pencils in a set. So how many pencils are in each set? He took 60 and he divided them. And I know he has 15 sets. So 60 pencils divided up equals 15 sets.